Good morning, everyone. My name is Salvador Ayala, and today I'm excited to talk to you about the digitization orchard data, building an efficient data pipeline for blueberry and apple. We will explore how data pipelines streamline the collection, processing, and utilization of data to make farming more efficiency, sustainable, and productive. A little bit about me: I'm a student from Heritage University. This is my first. It's gonna be my 4th year getting a degree in computer science. I'm from Mexico. I moved to America 6 years ago, and I started working in apples, cherries, and blueberries here in Washington, and also working in farms. Our motivation for these projects comes from three key areas: time saving, cost reduction, and efficiency scalability. By delivering data faster to growers, we enable timeline decision making and action, which is important in agriculture. We also want to reduce dependency on third-party service, cutting association costs and allow for internal data analysis at any time, enhancing flexibility and control. Finally, our goal is to provide 24/7 data access and analysis, improving operational efficiency and creating scalable solutions that can grow when the company's needs. But why are data pipelines so important in agriculture? If you think about it, handling such large volumes of data manually is impractical, right? Data pipelines automate this process, saving time and effort, keeping the data accurate and current, and allow farmers to make informed decisions at any time. Our project is all about improving how well we handle and use the data in agriculture. We were building robust data pipelines with Python to bring together and process information from various sources like green alleys and solar active systems. These projects help us by interact data to provide a complete picture of fields for informed decisions, ensuring timeline and accurate data for any time for like adjusting irrigations or planning for harvest, and offering scalability to handle more data as our farmers grow. Ultimately, improve resources management, efficiency, and yields. These benefits are improving crops management, allows farmers to make informed decisions about planting, watering, harvesting, for example, leading to better yields, right? Efficiency resources utilized ensure that, for example, the water, fertilizations, and other inputs are used ultimately reducing waste and costs. And enhanced sustainability means that farming practice can be more environmental friendly, preserving soil health and reducing the carbon footprint. By delivering data, we can achieve these benefits and create more products and more productivity and sustainability agriculture system. This slide is the outline of our goals. We want to get all the CSV files based to the Green Alice API. After, we want to compare the information that is existing already in the PostGIS database and make sure they align with the new client schemas. The final result is saving all the information client schema and organize our systems in our database. Let's look at a little example. The example on the right top, this is how the PG Amiring collects client data. And we can see in the blue line is demonstrating how January specifies IDs for each client, which is highlight if there's any error between the clients and the data. The example in the bottom demonstrates the creations of file in our environment after processing successfully the data in our system. This is what we need and this is what we're looking for, data flowing. But how are we gonna do this? We're gonna use some tools and some technology. In this case, we're gonna use Python, Panda, GeoPanda, Mampi. This is some library. There's more. And for our data, we're gonna use the PG admitting. Spider is gonna be for the coding and also for the debugging. While we develop our data pipeline, we incur several challenges. For example, we had to do everything manually. There was some lines of code where the behavior was wrong. There was some duplications, data, entries for repeated script runs, and also there was more issues specific for the database. We had to do also changes. We had to do update to the GID, the one is creating our ID for our clients, and for the blocks details for identification. Also, we add geometries for both tables. One is called block scan heat map, and the blue scan geometry, which are two tables unique for our clients. And we modify some lines to create data client schema, which is very important because now we can upload our files. Not just that, we also find errors debugging. We had to make some changes in the code. We update our lines, and we were doing some switch and changes in the CSS file and our data, so everything matched. We tested when the GScan ID 636, and now it was time to see the results. This is some of the results. Now we can see in our console that we had our clients running successfully in our system. If we follow the blue lines, now we see that we had the files, the 6 files, and now it's time to implement into the GeoPart Agriculture. The GeoPart Agriculture is just basically a platform where we can implement our data to analysis and to get the agricultural practices and improve crop yield. There's a representation on the right where we can see some examples about how that one looks. In this case, we have the total fruit, the size, etc. This is our results. The picture in the left, the visualization of the field data, that's a blue line circle in that field. That's a specific one using satellites. In this zone, we can find the soil data and crops yield information, helping detailedly find analysis and decision making. The one in the top example, the geodata visualization, we can see a colorful core areas which are representing the different geos level, and also we provide the statistics to instance into the fields. The one at the bottom, the comprehensive geomap analysis, that one has a detailed statistics provide an overview of geo distribution. We have the average geo and the variability, adding a price agriculture decision. This example is just a small representation about how can clients see their data, and they also can have different tools inside of this platform that they can use depending what they're looking for. Innovate, that's why they keep working so hard to keep empowering growers with the data. Their mission is to keep provide action to help them to improve yields and sustainability. This is why they use these two systems, the one I talked before, the Green Atlas system and the Soil Atlas, to collect all the data and analyze it and provide to the growers later. Looking ahead, adopting these new data techniques, it will be crucial for future and in agriculture. By using data, growers can make faster decisions, as I mentioned before, to precise decisions, optimize crop management, help the irrigation, help pest control. Data drives is really helpful to conserve water, to enhance soil health. Every grower should consider implement these advanced technologies and solutions to ensure a more sustainable and productive future. With this, I want acknowledgement the Ag Institute for giving me the opportunity to be part of this project. And I also want to thank to my team, Innovate Ag. Thank you, Steve Manto, for all the help, Felipe, Mateos, Freddy Baldomino, and thanks to the Ag Institute Jordan, job for always be there. When this, I want to conclude my presentations and I'm going to take any question. Thank you.